And we are live. Welcome to today's meetup about our DevOps benchmark results 2021. I give this a few more minutes to let people join. If you already joined, then feel free to say hi in the chat, maybe include your location to see whether we have an international crowd in this meetup. If you do so, please make sure to select all participants before sharing your message. Perfect, Andreas, great. Moin from Hamburg, nice.
Moin.
Very good. That's good, you selected everyone, that's good. Hi, Michael. So we'll give this a few more minutes to allow people to join, and then we'll get started. Maybe I can already. Hi from Moscow, nice. Canada, Los Angeles. So we do have an international crowd. I like that. Hi, everybody. That's great. Keep saying hi. It's cool. So maybe a few housekeeping rules. Moldova, nice. This meeting is being recorded, as you can see. So we'll share the recording with you tomorrow in an email. In that email, we'll also share the full report in case you don't have it yet. And the link to the benchmarking survey, in case you haven't answered the benchmarking survey yet. And so if you have questions in between while Kasper is presenting, feel free to either drop them in the chat. I just see Mark, hi. If you use the chat, I think also Roy, please make sure to select to everyone before you send a message, because otherwise only Kasper and I can read the message, which is also cool, but not as cool as if everybody can read it. So if you have questions, either use the chat or there's a Q&A function in Zoom that you can also use. Using the Q&A function has a few advantages, like your question will not get lost in the general chat. So feel free to use either of these ways to ask questions, and I'll either interrupt you, Kasper, while speaking, or I'll keep them for the end.
Very good.
So I think 3 minutes in, we have about 40 participants. I think this will raise a bit, but let's get started, I would say. So welcome again to this meetup about the benchmark results 2021 from our DevOps benchmark, where we learned something from more than 1,800 teams. It's really interesting, and I think it's the biggest study in that level of detail in the industry. I'm Christoph. I'm your host tonight. I'm currently working for Humanitech, and I'm here tonight with my colleague Kasper, who is the main responsible behind this survey. So glad we have you here, Kasper, and glad that you take the time to guide us through the results. I think you can introduce yourself, right? Floor is yours.
Thank you so much. Great to have you. It's amazing to see how many geographies this is now covering, like literally basically spanning the entire world. So a couple of us in the East are probably already asleep. We are going to publish this on different channels afterwards so they can watch as well. Anyhow, welcome, good to have you. I'm Kasper. I'm deeply interested in developer self-service, really. For the last 10 years, there's a little bit of a nerdy passion, but I fell in love with that. So here we are. And we sit on like tons of data. And at some point earlier this year, we thought, why don't we just take the reach that we have? I think we reached 2 million people or something on social in any given month, and actually gather more structured intelligence to give something back, and then actually show how people perform, how we can benchmark ourselves. And what we're actually interested in is how can we get better at what we're doing, and what are the things that people should focus on if they want to actually take the next steps in DevOps or really whatever. We are currently gathering data on Kubernetes, I think, and this is extremely exciting stuff. So what were people expecting around Kubernetes that they then didn't really see come true? I think we're at 600 data points, and I think we'll let it grow a little bit until we actually. But I looked at the preliminary results, and they're stunning. And we're doing the same thing for infrastructure as code and for a lot of other things. Anyhow, so this here is really around DevOps setups, and what we mean by that is, how do people arrange tooling, the cultural elements, and all of that. And what I'm going to cover today is, let's have a look why we did this. I mean, I explained this a little bit, what we found, and then what to do. So what are the steps that we can take to improve? And I really want to encourage you to interrupt me bluntly and ask questions, so we can make this as interactive as possible. And yeah, very happy to answer whatever question you may have. Well, let's dive right in. Whom did we survey? Well, in total, 1,851 teams. There is a certain focus on the geographies EMEA and the United States. And if we look at the total bucket, like if we would have surveyed everybody in this geolocation, those would be 20,000 teams. So we have a decent representation. The majority of teams had up to 30 developers, 29% had between 30 and 250, 3% didn't know, and then 12.3% had more than 250 developers. And we've controlled for this. There is a whole annex on how we made sure that the data is actually representative. If you have specific questions regarding that, fire off, and we can also look at this later. What did we actually ask? Well, three things primarily. Number one, the tech and infrastructure, right? So, I mean, DevOps is more philosophy, right? But if we look at the classical setups, people have different ways of doing CI and like dealing with the cloud and or on-prem, whatever. So we were interested in making sure we control for that and have a look at what people actually run. And then the second thing is the classic DevOps metrics: deployment frequency, lead time, mean time to recovery, and change failure rate. A lot has been written about this. And then really the team setup and culture, right? And we'll look at this. And from all of these things, we've composed a scoring. And the scoring, you could reach 0 to 100 scores, and depending on how well you performed in the different metrics. And we then mapped these teams. So this is the total volume of attendees of or organizations that took part in the survey, and we've mapped that against the different scoring. And then we actually clustered this, and we looked into 4 different buckets: the top performers with a score beyond 90, the high performers with a score between 70 and 89, so that is the third quartile, and then we have the mid performers with a score between 40 and 69, and the low performers with a score between 0 and 39. I don't think there was anyone with 0, but there were definitely some with 100. All right. What is actually interesting, and that's the first observation that we have here, is that there is this, what I refer to as the DevOps mountain of tiers. So a lot of teams actually make it to the middle group, if you want, but very, very few actually make it to the top. And most teams are stuck in the middle. And that is actually something that the industry consistently observes. If you look at the Puppet State report, the Accelerate report, you can consistently see that there is this bucket in between where people get stuck. And it doesn't really seem to evolve in the last years. And so this is really something that I want to try to find an answer for. And this is what we're going to do with the findings. So the first thing that we're going to look at is the tech and the setup. And I don't want to spend too much time on this. The first thing that we'll look at is the architecture. So are you rather running a distributed system? Are you running a monolith? And you can see what we roughly would have expected to see. The majority is now on a loosely coupled architecture with 58.2% of the total data set. And we have 34.3 monoliths. And you would also somewhat expect that the low performers have a larger degree of monoliths, and the top performers, the low performers have a like a predominantly monolithic architecture, and the top performers have a predominant loosely coupled architecture. So the question is whether we can derive something from that. I don't think so, and I don't think it's a particularly useful discussion to have. In some situations, in some scenarios, monolithic architectures make more sense, and in another situation, loosely coupled architectures make more sense. It's never a good idea to try to find a general rule for that. There's no rule of thumb. It really depends on the situation you're in. I think like scoring on architecture is not a good idea, and saying you have to get into a loosely coupled architecture to actually get into the top performing bucket is probably nonsense. But it's really interesting to look at the results in that way. All right, let's look at the infrastructure setup here. Again, the general average. We have almost the majority, 49.6% on public cloud, 25.3% on premise, and 72% are in the multi-cloud bucket. Also, that is really consistent. We're seeing over the years now that there are less people migrating into, or the absolute number of organizations migrating to the public cloud is decreasing. There's enough reason to believe that we will never see 100% public cloud, by the way, if you're looking at the trends and underlying cost structures. Really, there is no reason to believe that the public cloud is going to be significantly cheaper in the future. We're seeing more and more organizations actually stay on-prem, especially as workload systems and offerings like IBM integrated on-prem are evolving and making the maintenance of on-prem systems even better. So again, I'm not sure whether this is a proxy for whether you run a good DevOps setup or not. Now, containerizations, what we would expect, top performers are more likely to run containerized architectures. And I think this is sort of a pattern like containerization. If you really want to reap the benefits of the cloud and self-service and all of these things, containerization is probably something that you want to look at. So by now, the majority of teams is containerized, or they're at least in the direct process of migrating there. Very few are not planning to do that. Let's look at the orchestrators here. Very, very clear picture. The top performers are running Kubernetes. The low performers, even the low performers in the majority of cases are running Kubernetes. At that point, 56.3%. We have still a significant number on Docker Swarm. Actually, not a bad product. Also, Mesosphere, was rolled over by Kubernetes, but I personally like Mesosphere, for instance, quite a bit. But okay, the industry has settled on Kubernetes, and I think it's fair to assume that Kubernetes is the new legacy. So configuration as code, that is interesting, but also the predominant case. So do you store your configuration as code? In the Kubernetes world, those would be manifests, Helm charts, whatever. Low performers, 60.2%, top performers, 95.5%. I think this is fairly representative. Same for infrastructure as code. This is now really getting into mainstream. 92% of top performers do that. 29% of low performers. So we have a couple of things that they have to pick up, and it's obviously making things like disaster recovery a lot easier. Will have an impact on your MTTR and all of this. Well, in general, summing this up, I am not a big fan of relating these things, the technical setup, to then draw conclusions of the relative level of DevOps. Not only because that has not that much to do. In the strict sense, you can ship really fast with a monolith if you've set that up correctly, and if it makes sense for your team. It's really all a question on how you do things. We probably all agree that in a containerization can make things a lot easier. Configuration as code is probably becoming the standard, but it's not the predominant variable that will have an impact on this. All right, now let's look at the performance metrics. First of all, deployment frequency, and we'll see that the gap between top and low performers is widening. The top teams are shipping much faster. On-demand shipment for top and high performers is in the 50-60% realm, where for the low performers we're looking at 10%. You can see that the 40%, almost 40% of low performers are shipping once a month. 23% are shipping a few times per year, right? So there is a huge gap, the distribution that we would roughly expect. The same holds true for lead time. And just if you think about this, what this means, right? The lead time in minutes, right, for an engineer that is in a top performing organization versus more than a month in a low performing environment. You can build direct correlations, by the way, between the deployment velocity and the actual revenue growth of a company. Your former colleagues, Chris, I think you've worked with McKinsey for a while, brought out a great study that we can maybe send after this or link somewhere after this webinar. So
yeah, I'll do that.
This is really like money that organizations are losing, and they're not doing a great job here. MTTR, same thing, like mean time to recovery. We have less than an hour for the majority, but like imagine like a mid and low performer would need a day and 1 week. If you think about the amount of cash that they're draining, is just really insane. And the change failure rate as well, that is actually an interesting number, because it will never be a tremendously large amount, because what actually happens if the change failure rate is too high, the management will say, hey, please stop shipping that much and increase QA, and then all right, you will be back to the reduced deployment frequency. All right, again, what can we learn from this? Can we make a recommendation to tell engineers to deploy faster? Can we say, hey, please reduce your change failure rate? No. Definitely not. Like, this is nothing. We've just seen the interplay. I can say deploy more often, right? If we deploy more often, we will have a larger change failure rate. It's like a naive assumption to believe that this has gives us any indication what we can do better in DevOps. But now it's actually getting interesting. So bear with me. We are getting into the juicy stuff here: the team setup and culture. We ask a lot of things, but I think this is what stuck me most. We ask what describes best how DevOps tasks are managed in your organization, right? So how, and I mean, I have the big pleasure to see hundreds of teams every year. I think like in 21 was like specifically intense. I probably end the year with 300-400 setups that I've personally looked at, and it's something that I'm like a pattern that I'm seeing over and over again. You can basically differentiate between 3 types of DevOps management structures. Number 1 is a dedicated ops engineer that takes care of all of the DevOps tasks. And then app developers are strictly separated, don't really care much either about configuration or infrastructure. So in this world, this is the world you've all, like, if you've already been developing in the early 2000s, this is what you've probably experienced, right? So you have a couple of poor operations people or sysadmins sitting in the basement, and they get like stuff thrown over the fence, and somebody shouts at them, hey, can you please update my environment variable? And then you'll do that, and you'll ship the code, and everything breaks, and you roll back, and like all of this, right? So the typical idea of operations-led development. And like fascinating enough, if we look at the entire sample set, this is still the case in 21.2% of cases. So that means DevOps hasn't really landed in these teams. In 34.2% of cases, we have something that I personally call shadow operations. And that means some developers can do the DevOps tasks on their own, but they're constantly busy helping less experienced developers. Like 34.2% of cases. What that means in reality is we have like a team of, let's say, 7 people, to just take a subset. There will be 1 or 2 senior developers that feel comfortable navigating, let's say in the Kubernetes world, value YAML files and deal with Terraform and Jenkins, okay? And then you have like maybe some cloud operations people, and then you have the rest of the developers. And at some point, the management decided, oh, we're now in DevOps. That's what we hear a lot, because it's the latest shit, and everybody has to do everything. Now, the reality is modern delivery systems are super complex, right? So we're now living in a world where you have very complex architectures that you operate with dozens of different tools and that have to scale redundantly and globally across different data centers and serve thousands of users, hundreds, thousands of users. And it is much, much more complicated than the situation that we were in 20 years ago. And we're now throwing everything at everybody. And what actually happens is what I refer to as shadow operations. So the more experienced developers, the seniors, basically become operations, but the management then says, oh yeah, we're not doing DevOps. Well, congratulations, you've not really reached your goal. And then the remaining 44.6% of cases are on a you build it, you run it, where actually every developer does everything from idea to production. And what doing everything means is something that we are going to explore in just a second. All right, so this data is interesting, but it's nothing compared to if we dissect this between low and high performers. So this is the same graphic. To confuse you a little, we've used completely different colors, which doesn't make sense at all. And we are going to change this before we share this, this presentation. But if you look at this, the amount of dedicated operations people that do everything is all of a sudden at 33%, if I remember correctly, but it's we're all doing an interpretation of this graph right now, but I think it's something around 30 and 35%. So in 55% of cases, the people throw things over the fence and then somebody picks it up. Again, they're usually sitting in a basement and to like serve all the prejudices. And then they are deploying stuff and the developers wait and you get the hang. All right. Now in roughly 35–40% of cases, the developers, every developer can do some tasks. The management has proclaimed, hey, DevOps, but we're now in shadow operations. And below 10% of cases are running a true you build it, you run it. All right, and now the really interesting insights from the top performers. We're now back to our coloring scheme for some reason, and you can see that 100 of 100 organizations in the top performing bucket are following a true you build it, you run it approach. And I think this is really key to understand why what to do in order to actually reach a high-performing DevOps setup. And this is something that I want to explore now. Before we do this, one more thing that I find interesting, developer experience. Is that a priority for you as an organization? 68.5% yes, 16.8% no, and 14.7% have no idea what we were referring to. All right, let's look at these findings in particular. What does it mean, you build it, you run it, right? This is such an interesting question. First of all, when was this first coined? Werner Vogels, the CTO of AWS, if I recall correctly, 2008 or something, said, hey, we're now in the cloud world, we're now cloud native, and that means everybody does everything. What it actually means is that the developers are able to self-serve. They're able to take code from idea to production on their own and without taking ownership, understanding the context on how their code runs in production, and being able to cover the whole thing, idea to production, without being dependent on others, taking the ownership and the responsibility level, being able to respond fast, being able to roll back themselves, being able to add the environment variable, and all of that on their own. So the question is, does that now mean, and I think this is the key misconception why shadow operations is actually occurring, doesn't this now mean that everybody has to operate everything? And the answer is a definite no. So a good friend of mine, whom I'm now like working very closely with, who's just started another really cool company, Aaron Eriksson, has built the platform operations at Salesforce. And I really like this quote: "Service ownership is a good idea in theory, but in practice, people get confused. If developers have to run all the ops for their services, you do not have any economies of scale. To run 1,000 different services around Kubernetes, it shouldn't need 1,000 Kubernetes experts to do that." And that's the one thing. And even in Kubernetes, there are lots of different levels of how deep you want to go. Some people like deal with networking configs on EKS, and then there is the level of just changing some values in Helm, right? There's a sort of a huge variation of what that actually means. But Aaron is actually pointing at something that is very, very important. If you are throwing everything at everybody, you're increasing the cognitive load the individual is exposed to. And I think this is key if we think about self-service and you build it, you run it. We have to understand the concept of cognitive load, and we have to understand how this relates to what we're doing and how much allocation of brain capacity we really want to allocate to whom. And I wrote a longer article on this, and I've been sort of structuring my thoughts alongside this diagram. You can call this another random diagram, but it was helpful for me to sort of understand the interplay here. And what I did is that on the one axis, I mapped the sort of cognitive load. On the right-hand side, the complexity of the task at hand. What does cognitive load for me mean? My base assumption is, which I think holds true, is that developers are really clever people, right? And so they can potentially do everything. Like they can understand Terraform and like set up this module, and they definitely can understand Helm charts, not rocket science. And they can understand this and this, like all of these individual bits are absolutely like feasible. Like if people with all of their intelligence like throw time at this and cognitive load to manage this, they will definitely manage. And the question is, what are they willing to allocate? What is their cognitive load acceptance level, if you want? Now let's look at this. Rolling back some configuration is not as complex. It will require relatively little cognitive load, like dealing with advanced cluster networking or VPCing, VPN into a Cisco router, whatever, will need a little bit more. And so the more complexity, the more cognitive load. And what we have to, and what I think we have to embrace is that it is impossible at the complexity level we're operating today to let everybody do everything. And so what we have to distill, and there are various methods on how to actually nail this, is what is the individual's or the team's preference for cognitive load? Do they feel comfortable, given everything that they have to do right now, rolling back configurations and doing cluster networking? Or do they want to have a sort of handoff point where they say, this is how far I want to go, and then afterwards somebody else please takes over? In all of the high-performing engineering organizations I've ever seen, there are operations teams, there are cloud ops teams, there are experts dealing with infrastructure. And what they get really well is understanding what is the maximum amount of cognitive load? How can we give more training? And how can we enable developers to self-serve as much as possible? And then when they're overwhelmed, how can we design the handover between the individual developer in self-service and the actual operations team in the background? If we don't do this, let's not forget that we're back to the shadow operations role. So all of that is about striking the balance. So how do you do that? How do you actually strike the balance? And I want to share one story from Disney, actually. Another friend of mine, Nigel, is and I keep mispronouncing his last name, so I'll not say that. Nigel was an enterprise, a director of enterprise engineering at Disney, and he was responsible for defining this handover point at which until which developers could actually do everything, and then afterwards somebody else took over. And he had a great way of running hackathons every 3 months with development teams, and actually understanding in detail what they feel comfortable with, what they don't feel comfortable with, where they require more training. The key it comes down to is communication. Very, very little, I think in engineering teams in general, it's not super popular to sit down and say, what am I good at? What do I want to do? What do I not want to do? Because I actually want to focus on React. And then I often have the feeling that some don't want to speak up and say, hey, I understand Helm charts, but I actually don't want to operate them because I want to be the best at React or whatever. And so you have to have open communication. I'm sounding a little bit like an LinkedIn branding expert here, but it's extremely important. And you have to sit down, and I think hackathons, tooling hackathons, toolchain hackathons, we even do that internally at Humanitech, are something that can be really empowering, where every developer sits down every 3 months and builds or works on tooling that can help them on a daily basis. The second thing is golden paths over golden cages. You want to build abstractions, and we're going to look in just a second how we see a lot of teams do that, but you want to build golden paths, not golden cages. What I mean by that is you have to find the right level of abstraction for the team. And that, in my personal opinion, although I'm at times fighting with other members of the community about this, but I believe that this has to follow the weakest link in the chain. Abstractions should be developed for the most junior developer. But that at the same time means it can never be a golden cage. It has to be a abstraction that you can circumvent if you're a senior, if you feel comfortable doing this. Netflix calls them paved roads, right? Same concept. The next 3 things is educate. If you want to be able to, your team to deal with more cognitive load, you have to allocate more time educating them. Rarely happens because management always wants to have more features, but otherwise you'll not get into the perfect balance. And thinking about platform teams. Platform engineering is a huge trend that is currently developing and picking up. I mean, we're probably all coming from the name of our meetup, platform engineering meetup, platform engineering Slack, all of these things throwing around team topologies. Platform engineering is really, is in my opinion about acknowledging that there are several specialized functions in the team, embracing this, having a conversation about the perfect handover point, and designing golden paths, not golden cages. Somebody else I'm working a lot with, I don't want to do name dropping here, but it's actually people that I've interviewed and we've published the video, so I encourage you to have a look, is GitHub Jason, and he was the CTO at GitHub, and he made this quote: if you run a setup where dev and ops talk to each other, you don't have a great setup. Again, I wrote this in the newsletter. A lot of people reacted very angry. What I mean by that is by no means that you shouldn't talk to each other. What I actually mean is you really should talk to you. Oh, what Jason means, yes, talk to each other, but don't have transactional conversations, right? Like a conversation, hey, can you please add this environment variable to my, I don't know, React workload, is completely useless. You should do that yourself. You should check it in and then you should test it. And like, if it doesn't run, you can ask someone for help. You shouldn't have transactional conversations. You should actually have conversations around how can we improve the status quo? What is an abstraction level that you feel comfortable with? And I think what the GitHub team does really, really well is having that open conversation again and saying, what's the abstraction level that we actually want to build? All right. The next thing is something that Manuel Pais from Team Topology and Matthew from Team Topology have said over and over again, and the guys at Puppet, you have to, like, platform engineers then usually build platforms, self-service platforms, opaque abstraction levels if you want. And you have to treat these platforms as products, right? And that means, again, you have to ask your users and your developers, and you have to have a product manager, and you have to make sure that you actually like iterate on this and make it better and advance this and all of this. And it's almost trivial, but doesn't happen a lot. So what does that mean, platform engineering? Platform engineering is not really about like talking about things, not only talking about things, but then actually distilling what we've learned, the optimal abstraction level, and then taking every element of the tool chain. And just to remind ourselves, the average developer in the cloud native glorious world is operating 11 different tools, right? And so taking this and then gluing this into a platform product. And this is a graphic that I stole, I want to be very honest, from the slides from Adevinta. I think they held a great webinar. They made it's a great article. I very much recommend. We can link it, but I think if you want to Google it, how I built a PaaS for 1,500 engineers, very worth reading. And what that actually means is you want to have a CLI, you want to have a user interface or a sort of YAML format, however you want to do that, that matches the abstraction, the preferred abstraction level of your team, and then actually glues that into a consistent developer experience. And I often get the question, oh yeah, this is nice, but how do I actually start with this, right? I mean, what's the starting point? And there are now, this is such an interesting movement, a lot of great open source tools, a lot of great companies just starting up that are helping you build these platform APIs, aligning teams behind these systems. And if you just start up and say, what's the biggest pain that we want to abstract away, right? What I commonly see is, let's be as simple as adding an environment variable to a Helm chart, building a baseline Helm chart, CLI that adds to the Helm chart, creates context-specific manifests, is a prime pattern to start with. And you can start very lean. You can start with a surprisingly small team. It's not something that you can do if you're only Netflix. I'm seeing teams with 10, 20 developers start with this with tremendous results. All right. And now this was a slide that I actually wanted to show like bit by bit to increase your cognitive load and make it more interesting. But again, if you want to summarize everything that I've said, simplify to lower cognitive load, enable developer self-service to foster ownership. This is from all data and all the setups that I see or oversee at the moment, my key learning. And I hope this content serves you and helps you on your journey And now I'm really happy to take whatever question you have. But you can also always, I don't know, phone me or ping me on Twitter or wherever.
We'll share your contact details in the follow-up email. Absolutely. Cool. We have a few questions in the Q&A section. Let's start top to bottom. So Marlon is asking, regarding infrastructure setup, is there any information to the use of multi-clouds?
Yeah, yeah. So that is very consistent. And when I started looking at this, I thought, like, who would do multi-cloud? But like, that is a very arrogant thing to say, because a lot of organizations have to run multi-cloud. They don't do that. Everybody always says that, oh, you're stupid, you run multi-cloud, but that's actually not a choice that they can make. And that's actually consistently throughout the last 1-2 years, 16 to 20%, right? Like, I think that's a lot, right? I would have never guessed that. Why? Latency, specific services of cloud providers, and the largest chunk is geographical, jurisdictive restrictions. So if you're an American company and you want to do business in Russia or China, it's not a choice. Like, you have to use Alibaba Cloud or the Russian equivalent, or Tencent, right? You have to go multi-cloud. If you are in Europe and you want to comply with GDPR and you're in a security sensitive situation, you have to use Open Telecom Cloud, right? Which is, I don't know why, because they're running on Huawei. But I don't know, that's the legislation, right? This is the reality. If you do that, the key is the configuration management. Like, you can, that is almost always where the trouble actually come from. If you have your shit together in the way you strictly parameterize stuff, you work against baseline YAML files that you can then dynamically create for the respective cloud provider, then it's actually not as complicated to run multi-cloud. I've seen fairly stable results from teams with good setups running multi-clouds. It's definitely possible. That was a very long answer. Hope that helped.
Cool. Question from Igor. Is there a correlation between company size and cluster? And with cluster, I think he means like low performer, high performer, the clustering in the presentation. That's my interpretation. I hope I'm right with that.
Yeah, yeah, there is. So if you're, but it's a very, very small correlation. If you're a larger company, you're more likely to be in the lower performing bucket, which is telling us a little bit about the calibration of the scoring, because one should take that into account. Like, there is if you're a large team, by definition, you can't act like you're a 5-person startup. You have security, you have a lot of existing users, you will have to have more rigorous RBAC, and all of that will probably have an impact on your metrics. So we have to be a little careful if we look at these attributes. It's obvious that a team of 5 will on average ship faster than a very large team. But if you look at, there is actually an excellent book that I highly recommend to read by the CEO of Twilio. He only wrote one book. I think you can Google it, and then you'll find just that one.
Isn't it Ask Your Developer?
Yeah, exactly. Yes, yes. Ask Your Developer. And so what's really interesting with Twilio is that although they're a large organization, they're actually like breaking this up in really small chunks. And that means that there are lots of teams also competing to each other, right? And if you, very good. Yeah, plus points, very good. No, but like very worth reading. So there are lots of ways of dealing with this. If you, other interesting, like there was a guy at Amazon who was with them at 50 developers, 5,000 developers, 50,000 developers. And he was asked whether he felt any difference, and he didn't. And so I'm sometimes really, really worried if I look at especially old style German companies, European, but also US, the gap at the speed that they have in comparison to a Twilio is just I'm not sure how they are going to survive. I think this alone makes me very nervous.
All right. Understood. Let's move to the next question then. Gregory is asking, can you give some hints on how you might create abstractions that make things easier for junior devs without just giving people direct access to the raw things? Is there good tooling? Is it all custom CLI scripts?
There's great tooling. We're working in that space, and I don't want to do self-advertisement, but there are, in the general realm of internal developer platforms, more and more great offerings that can do just that, and that can strike the balance really well. Where at the one point, and what I think is really important, also for the junior developers, we should not get into a situation where, and I think this is all too easy to get into, where we're all of a sudden abstracting everything away and they have no idea that I know a couple of teams that are so abstracted, the developers, if you ask them, don't know whether they're running on Kubernetes or this or that. And so I don't think that this is a good idea either. So be a little careful there, but there are great tools that strike the balance and provide the abstraction level, but still give the developers a context on how their applications are actually running in production.
Cool. Next question, did you use DORA capabilities model within the survey?
No, we didn't.
Did you measure DevOps metrics in the survey, for example, onboarding time, cognitive load, etc.?
That is a great question. That is something that we're currently looking at for a whole developer-focused survey. It's like how you measure cognitive load is a difficult thing. What I'm really interested in is what's the total time allocated to operating applications by the development team. We have asked that, not in this survey, but in another. The preliminary results are really stunning. So we asked, what's the percentage of time, if you take your total deployments, you take 1,000 deployments, how often do you do the following things? How often do you change environment variables? How often do you add a service? How often do you onboard a colleague? How often do you roll back any of these things? And then we map that as a percentage, percentage of total deployments. And we ask, if you update an environment variable, how much time does the developer spend while waiting for this or doing it themselves, including errors? Then the equivalent for the operations team. And the results, but they're preliminary, like we're currently gathering more data and testing more thoroughly, are 53 hours that are wasted per week by an engineering team of 7 developers. So it's fairly intense. It's 15 to 16% inefficiency on the individual team level, again, focused on EMEA and the United States.
Cool. I'm really looking forward to these results coming out, but I think it'll take a bit more time. So another question from Roy is, how would you deal with very young developers without much experience?
I have a very mean answer to that and a more mature answer. So the more mature answer is, I would invest in training, really. And I think there's nothing else you can do. And like along the way, we cannot get into a situation where people don't understand the context of what they're doing. At that point, we can let them do, I don't know, low code. It's our job now, and it will continue to be our job to build very tailored solutions in an increasingly complex world. I'm really on the side of people that believes that we're just getting started, and we need to train them. And if as an organization, we are hiring very junior developers, we have to be ready to do considerable investments and pair them with seniors to bring them up to speed.
Cool. So Igor asks, is cognitive load might be similar to toil in Google SRE? What do you think? David already provided an answer. So in his opinion, they are quite different. Toil is work that should be automated. Enough repetition is actually reduce the cognitive load. Cognitive load arises from having to deal with complexity. I think that's a good answer from David there. Anything to add from your point of view, Kasper?
No, I think David is fine.
Cool, David, thanks. So last question, and I think that's good in terms of timing. We're running 5 minutes over, but I think that's good. So Machi is asking, what is the role of observability in the IDP setup?
Yeah, that's interesting. We just had Liz here last week, I think, or 2 weeks ago. I don't know.
2 weeks ago.
2 weeks ago, yeah. So I think you really want to watch that video. I think maybe we can send that as well.
This would be a long email, Kasper, but I try to make sure. Yes.
I know. But yeah, and she made a great point. With observability, it is fairly similar. We are much too often now in a situation where we have these massive aggregations thrown at people. The same applies as for the rest. You have to understand the context of how the numbers are aggregated across the different things to really understand what's happening under the hood. I have the same thing. In the morning, I get aggregated numbers. My response at this point is to actually look at what the person writing the numbers writes while delivering the numbers, because I can sense from the sentiments whether he or she believes it's positive or negative, because the numbers themselves don't tell me much. And I don't think that this is a very healthy thing. So observability has to be baked into the process at any point in time. I think good setups make sure that, for instance, every workload config comes with annotations for, what was the company's name? Honeycomb, whatever, or Datadog, to make sure that there's end-to-end observability, and you give the developers the context on how the aggregates were actually, or the numbers were actually aggregated. But I encourage you to look at that recording. She is much more of an expert than I could ever be.
Yeah, I'll share it. She was talking especially about open telemetry and stuff like that. It's really interesting to look at. And yes, there's a close correlation to IDPs. I agree. Cool. Those were the questions. So with that, I think we are done. A few minutes over. But I think that was good. Thanks everybody for attending. It was great to see like 50 to 60 people in this meetup. Really enjoyed it. Kasper, thank you for your presentation. I read the feedback that we should make sure that things are readable, even on a laptop screen. Some of our slides were not. I apologize for that. Good thing is, in the full report, everything is readable, and we'll share this tomorrow with you. So if you missed any of the numbers or couldn't read something, then go back to the report, look it up there. Thanks, everybody. Thanks, Kasper, for your time. This was great. I'm already looking forward to the next reports coming out, because I think there's much more to discover.
Absolutely. Thank you so much for your interest. It was much fun. Thank you for joining from so many parts of the world. If you have any questions, reach out. I love having in-person conversations. Not many actually take me up on that. And yeah, if you have any ideas or critique, or you want to work on stuff, just let us know. And join some of the next webinars. They're really, really interesting speakers coming up. I think there is Steve from ValueStream, the ValueStream guy. That will be really, really cool. I think there's Gregor Hooper at some point, the chief architect, one of the chief architects of Amazon Web Services, who is really like a great platform strategist. Yeah, I don't have to I think there are like tons of meetups and webinars coming. Make use of this. See you at one of the next ones, and stay healthy.
Bye.
Bye.